Hi everyone, welcome back. Today we're doing truncate sentence. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. So, these are pretty much words. And they are separated by a single space. There's no leading or trailing spaces behind. And each of the words consists of only uppercase and lowercase English letters, no punctuations. So these are all sentences. The first word and the second word consists of both uppercase and lowercase characters. The first letter is capital. The second word over here are all capital letters, so that is also considered as a word as well. In this case, these hello world words are all lowercase characters, but they are also words as well. We're given a sentence S and an integer K, and we want to truncate S such that it contains only the first K words and return S after truncating it. So for example, hello, how are you, contestant? This is a sentence with 5 words. And we are given K equals to 4, so we have to truncate the string such that it contains only 4 words like this. So that means this is truncated over here. And the words in S are hello, how are you, contestant, and you just give hello, how are you. For the second example, what is the solution to this problem? So in this case, there are 1, 2, 3, 4, 5, 6, 7. There are 7 words, and we will truncate it such that it contains only 4 words. What is the solution? So in this case, we will return what is the solution after truncating them. So for the final example, chopper is not a tanuki. That's a One Piece reference. In this case, there's 5 words. In this case, there's no need for any truncation because it contains exactly 5 words. There's no need to truncate any additional words after the 5th. In this case, S is a string. So this string length is from 1 to 500. So this is a very lenient length. K is in the range 1 to the number of words in S. And in this case, K can potentially be the same number of words in S, or it can be lesser than that, and at least 1. And S consists of only lowercase and uppercase English characters and spaces, as we discussed. And the words in S are separated by a single space, so just like this. And there are no leading or trailing spaces, so there's no need for us to call .strip on S to strip any excess leading or trailing spaces on the left and right. So let's get into it. One way we can do this is by calling .split on S and use a empty space as the delimiter to split the words by. And once we're done, we will get back a list of strings, and that corresponds to the number of words in S. So for example, if you do S equals to this string over here, if you let this be words equals to S.split, and you specify an empty string like this, then words will be equals to a list of string, and this will correspond to hello, how are you, contestant. And we are given K. So what we can do is we can say truncated words. Truncated words can be a list of string as well. So let's give this type hint over here. This is for tracing. And what we can do is we can use list slicing to slice only the number of words that we want. So we can do this by doing this. And the first parameter to the slicing is the index that you would like to start with. And the second parameter after the colon in string slicing is the index that you want exclusive of it. So in this case, if you want to slice up to K number of words, in this case, this will be 0 to K. And the reason why we specify K, even though K is exclusive, is because the indexes in words are 0 indexed. So remember, this is index 0, 1, 2, 3, 4, and 5. So if we wanted the first 5, notice that we pass in 5 as the index exclusive of it. So we're going to slice from 0 to 4. So in this case, passing in k is sufficient. And once you're done, you can join back this sentence, truncated s. We will use the same .join method, where this string here is the delimiter that will be placed between each word in truncated words. And because we want to form back a sentence, we will use a single space as the delimiter to put this space in between every single word in truncated words to form back the sentence. So this, in this case, just so that this is clear, these truncated words in this case, let's say k is equals to 4. So what this means is we will get only the words from index 0 to index 3. So 0, 1, 2, 3. So this will be equals to hello, how are you? And notice that this would give you back 4 words as specified by k. And truncated s in this case, truncated s will be equals to hello, how are you? And that's the answer. So this corresponds with example 1. So with that, let's get started with the implementation. Actually, isn't this the implementation? Yeah, this is the implementation. Okay, let's specify words to be list of strings. This will be s.split, and we are splitting by an empty string. So once we're done with words, let's get truncated words. This would be a copy of words, but is sliced such that we only have the first k words in words. So this will just be words until k. By the way, notice that I didn't put 0 here, because if you do not specify it, the string slicing syntax will assume that you're referring to 0. So there's no need for you to put 0 in front. And once you're done, we can get truncated s. This will be string equals to an empty space, dot join, and you pass in the truncated words, and that's the answer. We just return truncated s. So to be sure that this implementation is right, I will try tracing this with another example. Previously, I traced this with the first example. Let's try tracing with the second example. So s is equals to this. So let's remove this. S will be equals to this, this string here. And k, in this case, is 4. So words, in this case, s.split, words will be equals to a list of string, and this will be what is the solution to this problem. And truncated words, in this case, truncated words will be equals to words from 0 to index 4 exclusive, so 0 to 3. 0, 1, 2, 3. So this will give us back a list which contains what is the solution. And truncated s, if we join all words in this list together and put a space in between, then this will give us truncated s equals to what is the solution. So that's the answer. Does this correspond with what is the solution? Yep, that is. Looks like this is the answer. Let's run this on some test cases. This passes. Let's submit this. And we're done. 5.5%. Wow. Okay. I'll wonder. Okay. But anyway, for this time complexity, in this case, if we let n be the length of s, or let's say number of characters in s, and let's say m be the number of words in s. In this case, the split function here requires a full linear scan across the string in s. So in this case, instead of depending on number of words, it depends on the number of characters. So in this case, it's on. The time complexity will be on. Truncated words in this case would be dependent on the number of words in s. So to be specific, it will slice k. So the number of iterations that you need under the hood to slice this is up to OK. So OK. K is K. Okay, so OK. So if you want the first 5, then unfortunately you have to iterate up to 5 times in the words. So unfortunately, this does scale with respect to K as well. There's actually, you might be able to do some additional optimization for the slicing, but I think that's fine for the purpose of this question, since there's only 500 characters in S. I think this is more than enough. This solution is more than enough. Truncated S would be to join truncated words, and in this case, the more words you have to join, the more the more time this will take. So to be specific here, this will take OK as well. So if K is very high, then there will be more words to be iterated in this list of words to join them together. So this will take OK time. So to be specific, the time complexity is OM plus OK, O2K. But if we remove the coefficients, then it will just be OM plus OK. So in this case, we do not need M as well, actually. We just depend on K. And that's pretty much it for the time complexity. For the space complexity, let's remove all of those workings that we had for time complexity. In this case, words would be a copy of S. It's just that we put it in a list. So if S contains 100 characters, then this list will contain 100 characters worth of characters split across words. So let's just give this a loose space complexity of ON. Because if you have 100 characters in S, then this list will somehow contain 100 characters as well. Truncated words in this case, let's give this a space complexity of OM. Number of OK. Let's let it be OK, because if you give it a very high K, then truncated words would have that number of characters in OK. And similarly in truncated S, this is pretty much a copy of truncated words just joined together in a string. So space complexity in this case would be ON plus O2K. If you remove the coefficient, it will give you ON plus OK. And that's pretty much it for this demonstration. I hope this was useful. If you like this, please give us a like and subscribe, and we will see you in the next video.